So thanks to everybody for joining. So today we're going to be talking about how can we do face detection using OpenCVSharp. Not really an ML.NET topic, but still a machine learning computer vision task that you partake in C#. So it kind of fits. So cool. Again, thank you to A-Press. They're sponsoring us. We are going to be giving away another copy of the ML.NET Revealed book. It's a digital copy, so we'll just draw a name after the presentation's over, and I will contact you guys directly to let you know if you won. So a little bit about me. I've been doing coding for well over 15 years now. A good chunk of that has been in the .NET realm, mostly in C#. But I've branched out and done other things like Python, Golang, and now coming back around to getting heavy back into C# and .NET again, especially in the ML.NET space and all the cool things we can do now. In .NET and C# around machine learning. It's just an awesome time to be in this space. So what we're going to look at today is we're going to do a real quick brief overview of what OpenCVSharp is, and then we'll jump straight into demos, and we'll be doing for face detection on basically just a static image. Then we'll look at how we can do that on a webcam stream. We have covered those. We'll take a look at how we can actually place text on top of the screen, and we'll do that with a webcam example. And then we'll look at how we can place artifacts on the screen. In this case, we're going to do a transparent overlay on top of a static image. We will put a pair of sunglasses on a person after we've detected their face. So what is OpenCVSharp? It's basically, we got to look at OpenCV before we can look at OpenCVSharp. So OpenCV is an open source computer vision software library. You can do a lot with it. You can do image manipulation, so you can do all types of resizes, flips, rotations. You can do color manipulation. You can use it to do OCR, do barcode readers. Obviously, face detection is in there. And you can also train like face recognition models. So you could train it to learn who you are in an image, which is pretty cool. Originally developed by IBM back in 2000, so it's over 20 years old now. It's been around for a while. IBM doesn't maintain it anymore, but they were the ones who came up with this. And OpenCVSharp is basically what you think it is. It's a .NET wrapper. It's been around since 2013. It's had about 72 releases in that time. It is maintained by one user by the name of Shamat. I'm not sure if I'm pronouncing that name correct. But he does have 58 contributors helping out on this project. So there's a lot of stuff going into this, a lot of people helping out on it. And what's cool about OpenCVSharp is that it's modeled as close as possible to the OpenCV C++ API. And that's really important for the next slide. So what we found, my colleague Nate has helped out with a lot of this work. And what we found was when we started diving into OpenCVSharp, there's just not a ton of examples out there, even though it's been around for a long time. And I know a lot of people are using it. You can go look at the NuGet downloads to see. Like, it's getting used a lot, but there's not a lot of people blogging about it or showing examples. So it's been kind of difficult to find pure C# examples. But what's really nice is that there's a ton of Python examples out there. On just about anything you can think of. And since the OpenCVSharp folks took a lot of care and time to try to make the API look as identical to the other implementations, we can easily take that Python code and deconstruct it and convert it over to C# code pretty easily. And here's a list of examples showing you how easy that is, right? So
thank you.
Well, here we go. So if we want to load a hard cascade XML file, you can see there's a CV2 cascade classifier in Python. In C#, it's a new cascade classifier, pretty straightforward. Same thing with loading image. This is a little different, and there's a cv2.imread to get a JPEG file in. In C# you do a new mat, and a mat is basically sort of, you can think of it as an image, and for all intents and purposes in OpenCVSharp, it is an image. But it's not like a bitmap or like an image class from like ImageSharp. It's a little different, and the way you interact with it is a little different. but for all intents and purposes, it is an image. You can see if we want to show a window, open a window and show an image in there, it's a CV2IN show. So basically you can see back and forth. It's fairly straightforward to take Python code, turn it into C# code. When you're working with OpenCVSharp, there's a bunch of different flavors out there, and you want to make sure you're pulling in the right ones. So this is straight from their GitHub repository. This is straight off of their README file. And basically, you can see no matter what you're doing, you're going to be bringing in this first one here, the OpenCVSharp 4 package. You're probably going to be bringing in the OpenCVSharp 4 extensions. I have yet to find where I didn't need that package. And then you need to get down into these native bindings depending on where you're running. So this is very important. So when we go through our examples, I'm on a Windows machine today. So I've pulled in the OpenCVSharp runtime.win. I've done some of this on a Mac, so I would have pulled in the runtime OS X 10.15. But just keep that in mind that the managed libraries, you almost always are going to pair them with a native binding library as well. So we can jump straight into some demos. So we're doing all this today in, this is Visual Studio Code, and we're going to do all this in .NET Interactive Notebooks. And so if you're not familiar with the .NET Interactive Notebook, basically Python style Jupyter notebooks, but we can run .NET code in them. So a couple things to note in our structure here in this repo, because the link to this repo is provided at the end. In the data folder, we do have our har cascade XML files. Now, we're not going to go into depth on what har cascade is. There is a great link at the end of this presentation that you can go read, a very in-depth, detailed explanation on what har cascade is. But the high level is it's basically an algorithm that you can train to do face detection, right? And at the end of that training, you get these XML files that basically tell the machine how to go look at an image and determine if it's a face or not. It's pretty cool technology. It's been around for a while, and it works really well. And you can go to the OpenCV, the official OpenCV GitHub organization, and they have about a dozen of these files pre-built for you to use. So in this example, we have one that we're looking for eyes and a face, and then we have this one, the frontal face alt, which basically is just looking for a face in an image. Speaking of images, we have a bunch of images that we're going to try to run through. We have a single face image. We have a face image with multiples. And then we have an image with a lot of multiples. So we wanted to see how this is going to do against, what, I don't know, 30, 40 faces. And then we have our transparent sunglasses that we're going to add later. And then we have all the notebooks that basically just do each one of these functions. So let's jump into number one. So the first thing we need to do, as mentioned earlier, is we need to load our NuGet packages. And if you're new to .NET Interactive Notebooks, this is how you do it. Basically, there's this #R keyword, NuGet, and then whatever package you want to bring in. So we can just, I have to tell it, that's fine. Boom. Okay, so we can see that we've installed these packages. This is basically just grabbing the latest from NuGet. If we wanted to control which version that comes in, all we have to do is just do a, well, that didn't work. Basically just do a comma at the end plus the version, and it would actually pull in whatever specific version we're looking for. So now we have our NuGet packages loaded. We just have to bring in some using statements. That's good. All right, so now we can sort of dive through this code. Let's just run it real quick to show you what it's going to do. Cool. All right, so it loaded up the face, the single face, and it drew a box around the face that it detected. Pretty straightforward, pretty easy. So let's walk through the code and see exactly how that's happening. So the first thing we need to do is bring in whatever har cascade classifiers that we want to use. So in this case, we just want to bring in the frontal face alt. So we're just going to do a new cascade classifier. Basically, this color here is just, we're going to use that to draw the boxes around the image, right? So we just need some sort of color. This is just green 02550. And we're just saving that off for now. All right, so now we're going to start loading in our images, right? And this is where the matte objects come into play. And matte objects are very important to always dispose of these matte objects. They are disposables, and you've got to make sure you're cleaning up after yourself, because if you're going to see some code later where we run through a ton of these matte images to do the transparent overlays. And if we're not cleaning up these resources, you're going to introduce memory leaks very easily. So it's just very important to try to wrap these in using statements if you can. If you can't, just make sure you're cleaning up after yourself when you're done with them. So the first thing we're going to do is we're going to load in our source image, which is the single face image. And then the next thing is we're going to create a new empty matte image called gray image. And the reason we're doing this is face detection works best on black and white images. So the first thing we do is once we load our source image in, we actually call this CV2 convert color. We pass it whatever we want to convert. We want to pass it whatever we want that output to go into and what the conversion should be. So in this case, we're just saying convert blue, green, red to gray. And the next thing we do is we do the CV2 equalize the histogram. And if we look at what that does, it basically just normalizes the brightness and contrast, right? And you'll see this a lot in some of the Python code where you basically, once you convert it to grayscale, you just want to normalize the brightness and contrast because it makes the Cascade classifier work better. And then it's pretty straightforward after this. We basically just say, hey, for that classifier we just created, we want to detect multi-scale. So we want to detect as many faces in this image as we can, multiple scales. What image we want to detect on, which is the gray image, and the minimum size of the face. And this one's very important, and we'll see it in a little bit on why this is important. Because basically, this is saying, hey, if you find a face, if it's not 60 height by 60 width, if it's less than that, I don't want you to classify it as a face. And the reason we want to do things like this is because sometimes, depending on what your backgrounds look like, you can get artifacts in there that this will come back and say is a face, but you know it's not a face once you see the image. And we may be able to trick it into showing us that on the next one. So this is really good depending on sort of, what kind of images you have coming in. If you're a webcam, if your expected use case is a webcam and you know the face is going to be pretty big, basically centered in the frame, you can increase the size a lot to try to reduce false positives on the detection. But for right now, 60 by 60 is working pretty good for this image. We just console right line how many faces that we found, because again, this is a multi-detect, so it'll detect as many as it can. And then we just loop over the faces that we found. So we just do a simple for each over these. And basically what we can do is we can create a new matte. And again, you see here, I'm not doing a using statement. I'm introducing a memory leak here. That's okay for this. So basically what we do is we pass in the source image, which is our full-size image of the face, and the rectangle that was found inside that face. And then basically we get the detected, you know what, I don't think I'm using anything with this. I got some bad code here. I bet I can comment that out. Never mind. That was used for something later. You'll see that actually, I can take that out. That's used in the next example, my bad. So now that we have the faces, all we have to do is we're going to draw the rectangle. So we can do a CV2 rectangle on the source image, the rectangle that it found, the color, and the line size. And then we can call CV2 IMShowImage to open up a new window with a title of face detection to show the image. And then once you do an IMShow, you have to include this wait key. And the wait key is basically a way for the user to kill that window if you need them to. And the way this works is, this is basically just this number you pass is a millisecond of delay to wait, to look for a wait key, to look for a key press. So it doesn't really matter right now. If we pass in 0, this is basically saying we don't expect a wait key to come in. And this is what you would normally do if you're showing just a static image like we're doing today. We don't need a wait key. They can just hit the X on the window to kill it. But it'll come more into play when we look at the webcam demo here in a second. So again, we'll play this one more time. And it's doing exactly what we hope it'll do. So I'm going to stop right there and ask if there's any questions. All right, cool. I might keep going.
I have a question, sorry.
Yeah.
Yeah, okay, so my question is, like in the initial block, like the code editor in Jupyter Notebook, how do you actually know the default packages that are installed using this script?
I'm not sure I follow the question. Can you say it again? Okay,
so my question is, how do you know the default packages, like NuGet packages, that are available in this space, this workspace?
Yeah. So like right here. So like I'm just hitting that. Yeah. So there's two ways, right? You can do it like this and just say pull the latest and don't worry about it. Or you could actually, we could go to NuGet and see what the latest package is, or if we want to use a different one, right?
No, that's not actually the question. My question is, like for this environment, there should be some default C# packages that are available, or namespaces. So which default namespaces are available here?
So like in our using statements.
Yes, like what are the default ones available in this space?
Yeah. I want to see, let's see, .NET, I can't remember. So I think .NET Interactive is basically set up to use whatever the highest .NET you have installed. So in my case, I have .NET 6 installed. So from here, I can do it using on anything that's in .NET 6.
Okay.
Or I could pull in a package and just use a using statement from there. Is that answering your question?
Yeah. Thank you.
Okay, cool. All right. All right, cool. So let's look at the next one. So with this one, what we're going to try to do is we're going to not only detect the face, we're also going to detect eyes in the face. So we're going to do the same thing as before. We're going to install our packages. We're going to bring in our using statements. And then this code's going to look very similar, but a little different at the same time. So we're going to bring in two cascade files this time. So the same frontal face that we saw before. And then we're also going to bring in the eye cascade. And this is just going to be called nested. Same as before, we're just going to draw set a color that we want for to draw the rectangles. Similar as before, we're bringing in our face image and we're using a gray image. All this is really the same as before. But what we're going to do now is, now that we have our faces, we're actually going to loop through those and then try to do an additional detection of the eyes. So for each face rectangle and faces, we're going to do a new detected face image using the source image and the face rectangle. Now what this is doing is it's creating what's called an ROI, or region of interest. And basically all that means is this face rectangle, you can see it there, it's a rectangle object, right? So it basically just has an X and a Y and a height and a width. So when we pass a rectangle object into this new mat, we're saying, hey, take this source image and then pluck out this rectangle from that source image and stuff it into this mat. So now what we have is just a slice, a single rectangle slice from the source image that's now here. And we're doing that because we know we've detected a face at this point, right? And now we're going to try to look for eyes inside that face. So basically, it allows for the second detection to work on a smaller region of interest. And it just makes that work a little bit easier. Now, we're going to go ahead and draw the rectangle here. Probably we could have done that up here. Doesn't matter. We're going to draw the initial rectangle around the face. And then similar as before, we have our face image, this region image, so we're going to gray it out. It's probably already gray. It probably didn't need to do that. That's okay. We're just going to go ahead and convert it to gray again. And then on that, we're going to do another detect multiscale, but this time we're going to do it with the nested cascade, which is looking for eyes. And you can see here we're using a much smaller size this time, right? Because if we're saying that our face detection needs to be 60 by 60 rectangle, we shouldn't expect the eyes to be bigger than 60 by 60, so we're going to shoot for something much smaller, 30 by 30. And then once we, go ahead.
Yeah, sorry to interrupt. Could you zoom in?
Can I zoom in? Yeah, absolutely. Let's see. Is that better? More?
Yeah, sure. Thank you.
Okay, cool. All right, so now that we have detected our eyes, if we have any, we'll just loop over those. And we basically just create a new point. And basically all we're trying to do is just some simple math to basically try to find the center of the eye that we just detected. Right, now I'm not going to go too deep into this, but this is basically what this math is doing. It's saying for each one, just find me the center XY of the detected eye. Then we create a radius, and we're just going to basically, we're going to draw a circle this time around the eye. And basically all this is doing just some quick math again to take that center point, build a radius around it, and then we can draw a circle using that same color and the thickness. So now what we should get is a box around the face and then 2 circles around the eyes, if it works. Let's take a look. Boom. So now this is really cool, right? So it's kind of interesting. You can see that it drew a bigger circle here on the right eye or left eye, whichever one you want to, whichever how your perspective there, and a smaller one over here. And you know, that might be worrisome, it might not, especially when you start to do overlays, especially if you really wanted to get professional and try to drop like sunglasses on this guy, you'd probably want to look at the pinpoints of the eyes and figure out how big to make the image that way. But what's nice is that even though these circles are a little bit bigger, one's bigger than the other, the pinpoints should be right on the eyes or close to it. Now, what I forgot was that we actually do have other images in here. So let's take a look at the group and see how it does with that. Now, okay, so this is where we get into trying to control for the size of the box that it's finding, right? So in this case, it did find the faces, but it didn't find any eyes. And that's probably because in this image, these faces are much smaller. So if we look back at our size object here, when we're trying to look for the eyes, clearly we're going too big. So let's bump this down to 15 and 15. Let's see if this will find any eyes. Found a couple. Found a couple. And you can see, like, in this face, he's squinting a little bit because he's smiling. May not have found the eye here because of some of the shadowing from the hair. So you can see these aren't perfect. Let's drop it down to 10 to see if we can do any better. No, same result. Okay, so not perfect, but we are picking up some eyes now. Let's try it on the big faces. Oh, okay. You can see that we found a bunch of faces in this one. We found some eyes, but it's not perfect again. And you should notice a trend in this one a little bit is all these that didn't find a face, you can see they're kind of tilted a little bit. And then it found this one face here that's clearly not a face. It's made a little rectangle here over on the side. But all in all, it picked up quite a few. It picked up some eyes on most of them. But it's something to note, right, is that this tilted head, we probably would need to bring in a third classifier to try to pick up on this tilted head. Some of these with glasses, sometimes it doesn't do well with glasses. There are cascade classifiers specifically built for people wearing glasses. So it's just something where you need to sort of experiment with which classifier should we use? How big should we make the min size on our boxes, before it can really start to pick up things. And you can see here this woman, second woman in the fourth row, it picked up the corner of her mouth, thought that was an eye, right? So there's definitely some logic that needs to go into if you wanted to sort of productionalize some of this stuff to, potentially weed out some of these artifacts. Like in our case, if we wanted to try to productionalize this, we would probably say, I only care if there's one rectangle and two circles that are almost on the same X plane. Like that might be something we could do to sort of remove some of these weird artifacts that are showing up. Since we're doing that, let's go back over here to our first one, although it's kind of the same code. Yeah, that still works. Okay. So I'm going to stop there for a second on the face and eye detection to see if there's any questions. All right, cool. So now we'll jump into a webcam. Yeah, I want to save that. Sure. So now we'll jump over to the webcam. And what you're going to find here is that this code is going to look almost identical to everything you've seen so far. So this is the webcam example. Very similar to what we just looked at. We're going to try to find the face, draw a box around it. And we're going to try to find eyes and draw eyes around it. Now, the main difference here is that we're introducing this video capture. And no magic here. We're basically just saying, hey, we want to use a webcam that's attached to this computer. In my case, I only have one webcam. And so I can basically just say, hey, I want to create a video capture and use index 0. And that's basically because I have one camera. I know it's always going to be at index 0. If you have multiple cameras, you'll need to figure out which index you're at. I think this just takes an index. Yeah. 6 overloads. There might be, you might be able to do something else there, but for me, I only have one. I'm just going to go for index 0. Something else that's different here is that we are going to create a window up top here because we're going to be reusing the same window over and over again. But the rest of this is pretty straightforward. I mean, this is what you've seen before. We create the new source image, we create the gray image, we create the detected gray image, and we can basically, you can see I'm just sort of moving my using statements up a little bit. So once we fall into this, we basically just want to say, hey, while the webcam is open, and basically all this is saying is that the web camera is on and it's capturing an image. So for whatever reason, if you're in this loop and I were to go and unplug my webcam, this would come back as false and we'd fall out of this while. So this is just a handy little, just do it while the camera's on. So once we fall into this, the first thing we're going to do is just to capture a read. And this is basically just going to capture a frame from the web camera and put it into that source image mat. And then nothing else is changing here. All of this code is exactly the same. We're going to try to find our face. I'm going to change this to 60 to match another code. Similar as before, once we have a face rectangle, we're going to fall into this and try to find the eyes. We're going to try to draw the circles around those eyes. And then the only difference here is this window.showImage. We're going to, since we created this window object up here, we're reusing that down here. So I just want to say WindowShowImage. And then the wait key. Now I'm going to change this because I found out that 30 was way too long. I'm basically saying, hey, wait for just 1 millisecond to see if a key gets pressed. And this is very critical, right? Because this, we found out last night that this greatly affects how many frames per second you can capture in your webcam. So I just want to wait 1 millisecond between frames to see if a key gets pressed. And in this case, if the key is 27, which is escape, I want to break out of the loop, and then it'll shut the stream down. So let's play this. Now this does take a little bit to initialize. Connecting to the webcam, making it open and start capturing generally takes about 20 seconds, I found on my machine. Oh, there we go, cool. All right, so this is probably a little delayed on your side, but you can see my webcam's now open. It's tracking me, it's showing box around my face, it's tracking my eyes. Let's see if I can get it to there. It will pick up a corner of my mouth as an eye every now and then. But this is doing pretty good. And if I hit escape, so I'll stop there, see if there's any questions around capturing webcam data.
Yeah, I have a question.
Yeah.
So my question, you talked about the wait key.
Mm-hmm.
Yeah, but when does the wait key method gets executed? Because I'm saying that this is still a loop. Can you like explain the wait key function?
Yeah, so the wait key, so basically this is something that's, it's unique to OpenCV, right? So basically when you do an IM or CV2 IM show or a WindowShowImage here, it's expecting this CV2 wait key to be the very next line. And if I take that out, let's just take it out. And what's going to happen is, if I remember correctly, the window's not going to show at all. Let's check it out. Let's test it. So this is just something inherent to OpenCV. Like the minute you show a window, oh, it is going to show it. I don't think it's going to show the frames though. Yeah, we should have some frame data in here by now, and you can see it's not responding now. So, and I don't fully understand the internal workings of why why OpenCV does it this way. But basically, when you show a window, you have to have the CV2 wait key there. Otherwise, it's never going to show the image that you're looking for.
All right, thank you.
Is that kind of like a non-answer?
Yeah.
I wish I'd done a little bit more research so I could explain that better to you, but unfortunately, that's the best I can do. You gotta have it. And you can see like it's still running down here. So basically what I need to do now is do a cv2 dot. Let's destroy all windows. See now I've gotten my whole setup here in a bad state. So hang on 1 second. Normally what I have to do is kill Visual Studio. And then basically redo everything. So yeah, that's a lesson you'll learn pretty quick. It only takes a couple of times of you not including this to remember to do it every time. And then we'll talk a little bit about the millisecond delay here in a second when we look at the next example of displaying text on the screen. I just want to make sure I'm getting my code back to where it works. There we go. All right, we're back. All right, cool. Oh, and the cool thing here is that you can see that we are saying if the key equals 27, which is escape, that's the break, get out of the loop. If I try to kill this window, it's just going to come back every time. It's kind of crazy and kind of cool at the same time. All right. So let's look at the next example. So this is basically the exact same code we just looked at with only the addition of we're going to try to show our frames per second that we're getting from our webcam. So we just bring in a little bit of extra code here. We're going to be using systems.diagnostics to bring in a stopwatch. And there's nothing special here. This is basically just some code we pulled straight off the internet to determine our frames per second. So I'm not going to dig too deep into what's happening here. The big thing is that we just create a previous time, a new time. We have a stopwatch. We start the stopwatch. And then if we scroll down here after everything has happened, basically what we do is we figure out our frame. So we take the count that's happening. I should have shown that up here. So once we're in the while, we actually start incrementing our count. And basically we just divide that by the stopwatch elapsed milliseconds times 1,000. That's going to give us our frame rates. And then we're going to do this source image.put text. We're going to tell it what text we want on the screen. So in this case, we're going to put our current frame rate in. New point, this is basically just an X and Y coordinate on where we want it on the screen. What font we want to use. This is the font size, what color we want, and how thick the lines of the text are. And let's go back and look at this. So all the way up the top, just like before, we declared that green color for the box around the faces and the eyes. And what I'm doing here is I'm defining another color called FPS color, and this is red. A 255.00 is red. And basically what I'm saying is that if our frame rate is less than 20 frames per second, I want that color to be red. Otherwise, if it's greater than or equal to 20, I want it to be green. So what we should see is when this thing launches, we're not going to be at 20 frames per second at first. It's going to sort of creep up and get there. And then once it hits 20 frames per second, it should switch over to green. So let's take a look at that. Okay, there it is. Okay, cool. So you can see the text there. We're at 16 frames a second, 17. It's going up. We're getting there. You can see it's trying to detect a face somewhere over here. But hopefully we're going to get over 20 frames a second here, and we'll see this text go green. Cool. All right. All right, so that's basically how you can put text on the screen and maybe control the color. Oh, look at that, we dipped. So yeah, and you might be asking yourself right now, man, this thing should be getting about 60 frames a second. And we were thinking the same thing when we started this. We were thinking we should be getting 60 frames a second. What we found was there's a lot of talk online around why OpenCV will not get 60 frames a second. And there's so many variables that go into it. It's your webcam, it's your computer, it's the processes that are going on. There's just so many things that can affect what your FPS should be. And we've kind of mentally settled on if we can get 20 or more out of this thing, we're pretty happy. The video is a little choppy. It's probably way choppier over Skype. But for us, this is enough for what we're trying to do at the moment. So if we can hit 20 or higher, we're pretty happy with what we got. But I do want to show something around the wait key. So remember I talked about this is how many milliseconds it's going to wait to see if a key got pressed. And originally we had this at 30. And I don't know why. I can't remember why we had this at 30. I think it's just because we pulled some random code off the internet and we used it. But basically what we're saying is that we want to wait 30 milliseconds to see if a key gets pressed. And I want to show you what that does to your frame rates. Because now what's happening is we're capturing a frame, we're displaying that frame, then we're waiting 30 milliseconds to see if a key gets pressed. And then we're repeating that over and over again. So hopefully this thing's not going to make me a liar, because basically what we were finding before with that introduction of 30 milliseconds, there, it's holding right there at about 13 frames a second. So you definitely want to be conscious and cognizant of what type of delay you're putting into that wait key. In our case, we wanted it to be as low as absolutely possible. It cannot be 0. 0 will cause this webcam stream to just not display at all. So it's got to be something higher than 0, but it shouldn't be anything higher than 1, in my opinion. All right, so I'm going to stop there. It's 12:45. We got one more demo and example to look at, and then we can wrap up the presentation. So is there any questions around displaying text? All right, change that back to 1. Okay, so now we're going to look at how we can do image overlays on top of images. And I'm going to go ahead and admit right now that this code is not optimized in any way whatsoever. So everything that I talked about, how you need to dispose of your matte images, wrap them in using statements, I'm not doing any of that here. And that's mainly because I didn't have time to work this code out the way it should be. So we're just going to quick go through it, and you can hold my feet to the fire later. So we have this make overlay method, and we're going to look at that in just a second. But let's go back down here to the same code. So we've moved back to code that was in the original demo, just to keep things as simple as possible, right? So we're just looking for the frontal face alt from this classifier. We're bringing in that single face image. And then we are also bringing in this new matte, which we've called overlay, and we're bringing in the sunglasses. If you remember over here, these are a PNG of the transparent background. And when we bring these in, we want to use this IM read modes unchanged. And the reason for that is, remember how I talked about mattes or images, but they're kind of not images. What happens is a matte it basically holds a ton of information about this, and it also holds the channels of this image. So it's holding the red, blue, and green channels. So if we just do a new matte, we get an image that has a red, green, and blue channel, just 3 channels. But our PNG actually has 4 channels, right? Because it has that transparent channel, so we know which pixels are transparent. So if we don't say bring it in unchanged, it will bring it in as a 3 channel, and we'll lose the transparency on it. So we have to take special care when we're dealing with transparent images or anything that doesn't have 3 channels. So this all looks pretty much the same. We're just loading the images. We're looking for the face. But this time around, we're not actually going to draw the rectangle on the face, because this is not what our goal is. Our goal is to actually put some sunglasses on this dude's face. So we're not going to draw a rectangle. What we're going to do is we're going to call this make overlay. We're going to pass the overlay matte that we want to use and the source image. And that's going to return us back an overlay sourced image. Now, given the time, we're going to run through this code very fast, but I've put comments on everything, so hopefully it will make sense if you're going to look at it in GitHub repo later. Now, I'm cheating here. I'm 100% cheating. This is all hard-coded because I just need this demo to work. And the reason I'm cheating is that I'm providing the height and width of the overlay hard-coded, and I'm providing the X and Y coordinates where I want that overlay to land hard-coded. What you would do in real life is this make overlay would take probably an X and Y coordinates of where you want to put it, because you'd be loading your image, you'd find the rectangle face, you would get some coordinates out of there, you'd do some math, and then you would pass that X and Y into this so it would know where to put that, put those sunglasses. I didn't have time to do that, unfortunately. So what we're doing here is we're faking it. I know exactly where I want those sunglasses to land, and it is on 114 and 120. I probably don't need this here, this resize. This was originally here in that we wanted to put these overlays onto webcam video. So that rectangle that's being drawn is constantly changing height and width. And as such, the overlay we need to put on would be constantly changing height and width. So basically all this does is it would resize the overlay image for us based on how big the rectangle was. Again, I don't need this here because we're cheating, but this is just something to take into mind if you're going to do this in real life. So the first thing we need to do, since we're using a transparent image, is we need to pull our transparent layer out. And basically, all these layers are indexed in the mat. So I think it's RGB, red, green, blue. So red is at index 0, green is at index 1, blue is at index 2, and our transparent is at index 3. So that's the first thing we want to do, because we need to preserve this transparent channel. So then the next thing we do is we're going to take the overlay and we're going to convert it over to an RGB. So we're basically going to get rid of the transparent layer. So we create a new mat called Overlay Converted Colors. We're going to convert the color, passing in the original overlay, where we want it to land, and what we want it to convert to. And this is all very confusing at first, but as you go through it a lot, you start to understand really well what's happening. So now we have our overlay that's been converted into a 3-channel. So we took the 4-channel, converted it into a 3-channel, preserving the transparent channel. And basically what happens is when you start combining mats in OpenCV, the channels have to match. This is very important. Height and width has to match, number of channels have to match. So since we want to put this transparent layer back in, we have to create, wait a minute, I'm getting confused now. Wait a minute, hold on. Oh no, I'm sorry, we convert it. Yeah, there we go. We convert it to a 3-channel RGB. That's right. Okay, I'm sorry. I'm so confused because I'm kind of new to this as well. We take our original overlay, we convert it to RGB. The alpha channel is still in here at this point. We create a new array because basically what we want to do now is loop through and basically just pull out the RGB channels from our original overlay. And this is what this is doing. So on a loop, we're just saying, if the current index is less than or equal to 2, so we should only get 0, 1, and 2 indexes, we're going to extract the channel from the overlay and add it to that array. So what we're left with down here is the overlay merge converted colors mat, is we're basically saying CV2, OpenCV merge all the channels you got in this mat array into this one new mat. Okay, I'm up to speed now. Sorry about that. So now what we have is our alpha channel, which is just the transparency of the overlay. And now we've extracted the red, green, and blue, and we've merged them down into this one mat. Now it's going to get even trickier. So since now we have our overlay merged to a 3-channel red, green, and blue, we want to put our transparency channel back onto that, but we can't merge a single channel with a 3-channel mat. So we have to take our overlay alpha channel and actually merge it 3 times into a new mat called overlay alpha 3-channel. Then we can combine them back. And we're not going to get into bitwise and, bitwise or, bitwise not. There's a great article I've linked into the presentation that explains what this does. But at a super high level, it'll take 2 images and it will flip pixels on and off based on what you use, the and or not. It's complicated. The article I've linked gives a great example. It has a ton of image examples showing you what happens when you use the different and or nots. So I'll let you read that. So the next thing what we do is we're going to get the region of interest on where we want to put the sunglasses. And again, we're cheating. We know the height and width. We know the X and Y. We define them up here. So then basically what we do is the face that got passed in, we're going to pull that rectangle out. And this is our face region of interest. And this, again, this goes back to, we want to take these sunglasses and put them on the image, but you can't combine a mat of a different size with a mat of a different size. They've got to be the same size. So that's why we pull this rectangle out. We're going to do some magic. I'm not going to go through this, but we basically do some bitwise knots, some bitwise and some bitwise ors to basically take that rectangle we just pulled out of the face and put those sunglasses on top of it and keeping the transparency in place. And then basically what we can do is we can take the final region of interest that now is that rectangle we pulled out, we put the sunglasses on it, and now we're just going to stick it right back on the face in the same spot we took it out of. And we're going to return that face. So if this works, we've got some sunglasses on the face. So I know that was a super quick, super fast walkthrough of something that is extraordinarily complicated. Are there any questions?
No, it's fine.
No.
Can you hear me?
Yeah, I can hear you.
Hi. Hey, thanks for the great talk. The samples are really good and good to see the .NET ecosystem evolving and having some great things in it. So I just have one question. Can we run this CV Sharp on a microcontroller such as Raspberry Pi?
Yes, you should be able to. Now, I will say that I have not gotten that far. But if we look back at the different flavors, there is a Linux ARM here, and I'm pretty sure that's the one you're going to bring in to run on Pi. I do have plans to actually get some of this code deployed to a Pi. I just haven't made it that far yet. But everything I'm reading online is that, yes, that should be absolutely doable.
Good. Looks great.
All right, so I'm just going to get back into this real quick because I only have a couple slides. So pros and cons of OpenCVSharp. It's easy to use. Like, it's very easy to use. If you're familiar with .NET, C#, you're going to be able to dive into this pretty quickly. As shown in the previous slide, it's fairly easy to take Python examples and convert them over to .NET. It took us a little bit to get that overlay to work properly, but honestly, it only took us maybe 3 or 4 hours to really dissect the Python code and convert it over to C#. It's fast, because again, it's binding down to C++. It's very fast. And as we saw in this demo, we can use it with .NET Interactive. So if you're coming from a Python and you're used to Jupyter Notebooks, you can have that same sort of experience. Some of the cons, not as heavily used as OpenCV and like Python. So finding examples online can be tricky at times. Not a ton of examples online. And then I have long-term support in here as a question mark. And I only put that in there because it is maintained by a single person. There are a lot of people contributing to it. But I would still feel comfortable putting this out in the wild in production. But that's just something to think about. Q&A, we did some Q&A, but if you guys have some more questions, just let me know. But here's all the references. So I do have the link to the OpenCVSharp GitHub sponsors. Please sponsor this guy. If you're using OpenCVSharp, you can go give him $1, $2, $5, whatever you want to give him. I sent him some money because I've been really enjoying what he's doing, and I know there's a lot of work that goes into this. This blog post talks about the hard cascades. It's a great deep dive into what they do and how they're built. This is a blog post from PyImage Search. This is a great article on what bitwise and or XOR not does. The image overlays, this is the actual blog post that we use to deconstruct that Python code into C# code. So, if you're interested in seeing the Python implementation of that overlay, it's here. And then my GitHub repo. So again, I will link all of this I'll send an email out via the meetup so everybody can get this. I'll give you the link to the GitHub repo, which will include this presentation. And if you guys have any questions, you can always hit me up in the Discord channel or just email me through the meetup. So before we wrap, are there any other questions?
Yeah, I have something to say. And what I have to say is that prior to I joining this event, this online meetup, I had an issue accessing the link. So I don't know if it's from my side, but I think you should maybe update it. The one on Meetup.
The one in the middle?
On Meetup, like the link, the Meetup link.
Oh, the Meetup link. Okay, yeah. I got you.
I had issues accessing this meeting.
Okay, all right, fair. I'll do that, absolutely.
Yeah.
Cool. All right, well, thanks everybody for joining. Thanks for the questions. This has been awesome, and I really appreciate it. And please hit me up if you got any other questions.